All right, welcome to Rapid Fire Manufacturing. I'm with Bradley Emerick. Thanks for joining.
Thank
We're at MicroPulse, and also this is RMP. I know it's your sister company.
Yep.
If you don't mind, Bradley, kind of walk through your background, how you got into manufacturing.
Absolutely. Thanks again for having me. So my dad actually started MicroPulse the week I was born. So I've kind of grown up around manufacturing, and just with my personality was really drawn into the idea of creating things, and especially things that go into people's bodies to improve their lives. Just always been drawn to it. Education wise, I went into engineering, biomedical engineering degree from Rose Hulman, and then went to work in the orthopedic industry at an OEM after college.
That's awesome. So I remember you gave me a quick tour, and to see the house that you grew up in is still attached. So you were running around on the playground
Yep.
while, your dad was in the shop, and you said
Yeah.
kind of running through the shop, I imagine, as a kid.
Yeah. It was just part of our lives growing up. We had a fort in the backyard that was made out of a box that one of the CNC machines came in that my dad built for us into a fort. So it was just part of life.
That's amazing. When you think of orthopedic, like I kind of want to know about the stories behind some patients that you've helped.
Absolutely.
Like, if you don't mind sharing some of those.
Yeah, I would say that the most impactful for me in my life in the OEMs was I was working on shoulder replacement implants and instruments at the time. And one of the projects was a revision shoulder. So that means after somebody gets a shoulder replacement, if that one fails for any reason, the surgeon needs to go back in and replace it with another replacement. So that's what a revision is. So a lot of times those are really complicated cases because the idea of going into that person again with the trauma they've already had, taking that implant out, a lot of times there's bone loss, soft tissue damage. So a lot of times the people that need a revision have limited or no function in that limb or that joint.
Yeah.
So some of the projects we worked on from a revision perspective, we were actually giving that person their mobility back in their shoulder to do things that a lot of us just take for granted. So hearing those stories, being in those operating rooms and experiencing that was really powerful for me.
That's amazing, because you're manufacturing the products that are improving people's lives and in some instances saving them, right?
It can be, yeah. For people that are used to being active, especially when they lose that ability to move in a natural way, it can affect more than their physical health. It's a complete mental, physical experience. So when somebody regains something that they had lost, there's really kind of a profound transformation that goes on there.
Absolutely. One thing I noticed too is when you get into the orthopedic manufacturing, there's so many different processes and machines and stuff that you use. Can you kind of talk about that? Because I feel like it's so vast that you really kind of encompass a lot of different manufacturing processes.
Yeah, and I kind of go back to the beginning with that being the first machine that started MicroPulse was a wire EDM, and it has a lot of capabilities, but it's really limited with certain types of manufacturing. So over the years, we've expanded into so many different types of machines, from lathes, Swisses, CNC mills. We have automation feeding those machines, everything from laser cutters to water jets to 3D printing capabilities of titanium. All of those together help us offer what we like to say is a one-stop shop almost, or vertical integration, whatever you want to call it. We just want to make it easy for our customers to buy things, right? To receive the product that they need so that they can serve their patients. And that hasn't been, an overnight process for us. It's taken 37 years to get to this point, and we're continuing to grow.
Yeah,
and
absolutely.
add capability.
The vertical integration, that's always interesting too. What kind of led you guys to that? Was it simply because of customer need? Can you control your own supply chain essentially?
Yeah, that's a big piece of it. I think what we've done really well is we've put great people in place here, first and foremost, because we can have all these different types of machines and all these capabilities. If we don't have great people, knowledgeable people, experienced people, people that care about their job really, and about our customers, all that equipment doesn't really matter. So that is the number one thing as far as being able to serve our customers effectively, is having people that can get the job done. The other piece is listening to the customer, even their message under the surface, being, if they're whether complaining about something or talking about something that went well, there is something to be learned from that. And I think what we've learned over the years is there is a great desire by our customers to have to manage less themselves, and they have a great desire to be able to trust a partner to get a lot of this, upstream work done. So for us, that's really meant different machining capabilities, but it's also meant adding sterile packaging to our product lineup so that we can deliver the part in its finished final state to our customer, and they can then send that to the hospital. And that's meant reaching into raw materials with ultra-high molecular weight polyethylene at RMP. It's a mouthful. We call it UHMW for short. But that's just another piece in our puzzle of, not that we don't trust other suppliers. It's just, are there other things that fit into our capabilities, into our niche with respect to orthopedics, that broaden our capability to be able to serve our customers better? And that, it all comes back to that. If our customers are satisfied, if we do what we say we're going to do, when we say we're going to do it, that's easy to talk about, but that's something we strive for every day here.
Yeah, that's wonderful. When you get into some of these new processes, how does that look like? Do you go to a facility and figure out how they're doing it and sort of implement, or do you hire someone that already has that knowledge and they can kind of set up?
That's a great question. So when it comes to a few of the most recent product lines that we've added, and some of those most recent ones are 20 years ago now, but I think about case and tray. We did have a couple people that had experience in that world, because it is quite a bit different in some ways than the other types of manufacturing we do. So that was a long ramp up for us to really feel like we had an expertise in that area. But it did take having some people with experience. But I would also say that a lot of the people that were already here and that have been here are just very interested in learning new things and optimizing whatever it may be. So there could be things that we're doing, whether in case and tray, the same's true for sterile packaging, things that we're doing that maybe others aren't, just because there's a curiosity and a creativity that is going on that I think really helps drive some of that innovation. The story's pretty similar for RMP, had some experts, still have experts that are very experienced with that material from a chemistry perspective, from an engineering perspective, on the processing side of that. Raw material consolidation in polymers is very unlike machining, subtractive or additive for metals. So that was another learning curve that we got to sink our teeth into. And again, none of these have been overnight plug and play things that we've done, but we're just really proud of the people that have just dedicated themselves to learning, failing quickly, and overcoming obstacles.
That's awesome too, because you're empowering your workforce to learn more. It's like, hey, now you spearhead this, whether it's sterilization and packaging or the sintering, have a couple people that are like, I'm curious to learn, and let's really focus on that.
Yep. Dive in.
Yeah, that's awesome. One thing I noticed, besides the fact that it's absolutely gorgeous out on the floor, you can definitely, wouldn't advise eating off the floor, but that's about as close as you can get.
Yeah, absolutely.
How much has lean manufacturing played an impact on your setup out there?
Yeah, so for MicroPulse and RMP, I wouldn't say that we have an army of people that are constantly going around and using a lot of the buzzwords with respect to that, but it is very much part of our DNA, I would say. Being organized helps you be efficient. Efficiency helps you get a lot of work done. So if you're not organized and you don't know where things are, you don't know who to go to with certain questions, you're going to have a hard time taking on more work or getting the work you have out the door on time in a high quality manner. So, that has evolved in a lot of ways over the years for us, whether it's having a group of people that help manage that in between departments or in between the different machining cells that we have, keeping things organized. But a lot of that goes back to the culture of, organization, the quality management system, kind of driving how we operate rather than us trying to fit what we do into parts of a quality system.
Yeah,
if that makes sense.
Absolutely. Getting back into when you first started working here, what kind of tasks were you?
When I first started here, I was in high school and I was essentially shadowing experienced machinists. And when they would set up a machine, like a lathe, for example, making bone screws, I was basically ensuring the machine wasn't erroring out, and then inspecting some basic dimensions on these bone screws as they came out of the machine. So it wasn't that I was adding a ton of value at the time, but I was starting to experience just the importance of those people that have been doing this a long time, how they go about their thought processes. And maybe it's something that we've made forever, and they're always thinking about, how could we do this, higher quality, more efficiently, things like that. So that was really my first taste of it. In college, I did a couple internships here at MicroPulse or at related businesses as well. So that included while the case and tray group was getting started, and we were still kick riveting the brackets onto the case bases. This was a long time ago. There's no job that was too unimportant for anyone in this place. And I think that is another piece of our culture of people are willing to teach. We're not holding on to information in little pockets. We're trying to grow the whole place.
That's incredibly important. As far as technologies being used for implants and some of the other products you have out there, how have you seen those changing over time?
Yeah, I think one of the big things over time has been a real focus on what we call cementless implantation. So what that looks like a lot of times is having some kind of porosity either added to or inherent to the implant. So that can look like a plasma spray coating, lots of different types of coatings out there. It can look like having a 3D printed piece, whether out of a polymer like PEEK or out of titanium. And the important piece of having a cementless implantation is that you're much more likely to have the body accept that implant and grow onto it and hold onto it for a long period of time. Whereas the alternative historically is to have what's called a cemented implantation. So the surgeon's literally gluing the implant into the body. There's good initial fixation, and sometimes it can last a long time. However, there is a risk that the body will actually grow away from that glue. Over time, that results in loosening of the implant, and that loosening causes micromotion, which causes small particles to be created. The body then attacks those, results in inflammation, and then the final step of that process is the surgeon has to go in and take that implant out and put something else back in.
Okay. And then essentially, depending on where it is, like say your vertebrae, like that could be the strongest part now because it has a cement. So then your other... Right?
Exactly. Yeah.
Okay.
So the more you constrain, especially in your spine, all these different levels, they all interact together when we're doing just, natural function.
Yeah.
So when you constrain those, it puts that much more stress on the adjacent levels, especially in the spine. So what we see a lot is, you repair one level of the spine, but a lot of times the next levels adjacent to that level start to have issues eventually.
Yeah.
So, there's a lot of effort going into R&D to figure out how can we make these implants more effectively replicate the natural function of whatever we're replacing. And I think to a great extent, we've done that pretty well. We being the broad orthopedic industry all over the world, we've done that pretty well with large joints knees and hips, especially shoulders also. The spine, I think there's still a lot of new development going on with respect to motion preservation. And there's some exciting things that a lot of these OEMs are working on, small and large customers.
That's awesome. Yeah. And that piece you showed out there for the spine is really cool. So what are some exciting things that you're working on for RM?
So kind of along the lines of the cementless implantation topic, we have what's called direct compression molding of the UHMW PE onto 3D printed or cast metal components. So what we're able to do there is take a more complex design and mold the polymer directly onto the metal piece, because historically what's done is we snap the polyethylene or the UHMW onto a metal piece, and there has to be that interaction, that snapping function that takes up space. So we've been doing a lot of work with molding the polyethylene directly onto these metal components, and that gives the OEM a little more flexibility with how they design their implants to meet the surgeon's needs. So we're pretty excited about some of the implants that we're able to direct compression mold over at RMP.
Really cool. As far as sort of the future, I know it's hard to predict, but kind of where do you see everything trending toward?
Yeah, there's a lot of paths that I think are already being embarked upon. One of those that we're heavily involved in is continuing to innovate the materials that we use for these orthopedic implants, especially on the polyethylene side. There's different ways that we can modify or add to the material itself to make it more robust in the applications that it's used in the body, to give it more longevity, to make it tougher to withstand repeated abuse, so that these implants can last 10, 20, 30 plus years. I think broader in the industry, there's tons of interest in, okay, how do we cure osteoarthritis in the first place so that we never have to get to this point? That's been a question for many years. There's just a lot of things that are complex that go into, all right, why are we getting to this point in our bodies in the first place? Why can't they, go ahead and repair themselves like a lot of the rest of our body does? There's a lot that goes into that with blood flow availability, and things like that. So there's a lot of work going into that. That could be a risk to our business to some extent, but I think we would be confident that we could adapt into, whatever would also come next with that. Still, there's things like trauma that are unrelated to arthritis typically. And then the spine's interaction, within its column is a little bit different than your typical joint as well. So there's so many different areas that we want to innovate in as a industry. Part of the focus of a lot of our customers at the moment is on enabling technologies, which is a fancy word to say robotic surgery. So guidance systems to make the surgery more repeatable is really important for outcomes that the robot can do to make sure that cuts are exactly in the right place. The preoperative planning that goes into that, utilizing 3D imaging for the surgeon to visualize the surgery before he even cuts the patient open, is a huge thing that's going on as well. And all of this goes into making the patient's experience better, especially coming out of that surgery with respect to how that implant functions, but also keeping them from having to come back to have it revised or replaced.
Yeah. So, I don't want to say less intrusive because you're still doing the surgery, but probably less pain associated after.
There can be, yeah. When you think about some common problems that have persisted in the industry for the patients themselves, whether that is related to, kind of incorrect sizing of the implant, because everybody's body is different. So the surgeon goes in before preoperative planning, they had a whole kit full of different sizes of instruments of trials so that they could try it out and see which size they thought would fit best. That process has gotten significantly faster, in my opinion, because of that preoperative planning. So the surgeon is more likely to have a at least narrowed of sizes of implant that they're going to put in. And it's, I believe, more likely that this patient is going to get the exact right size for them. Because if you're overstuffed, is a common term,
Yeah.
in your knee, it's just not going to feel quite right. There will be pain. There will be kind of some loss of motion. And that's just something that person has to live with. So if we can just be more accurate in sizing, and there's many, many other things that go into surgery. Obviously, I'm not a doctor. So yeah, the patient focus of this industry, we cannot lose sight of.
Absolutely.
Because at the end of the day, that is the final customer, is just people.
Yes.
Everyday people doing life, and we're trying to enable them to get back to, life as they want to live it.
Oh, that's phenomenal. So Bradley, I appreciate your time. Maybe next time we'll go to RMP and do something there. So
We'd be happy to have you. Thank you for your time.